Hi everyone, welcome back to GridPro. Starting this week, we're launching a new YouTube series to help you get familiar with the new features in GridPro version 10. In today's video, we'll begin with the Autoblock Nozzle feature. The Autoblock Nozzle helps create automatic blocking for a nozzle by providing input surfaces, saving the valuable time otherwise required for manual topology creation. Here, we have a 3D model of a rocket with a nozzle, created in GridPro's CAD panel by revolving the 2D linear profiles. Let's start by creating a domain for the nozzle. We'll make a small cylindrical domain for better visibility and understanding of the geometry. Approach for creating domain. We'll create two DCAD edges and revolve them 360 degrees to form a cylindrical domain. The coordinates of existing vertices can be viewed by right-clicking and enabling the vertex information. You can right-click on a vertex and select Copy to copy its coordinates into the node creation dialog box. Now, we'll change only the Y coordinate to create a new vertex at the desired distance along the Y-axis. Clicking on Create will generate the new vertex at that location. Similarly, let's create another vertex for the length of the domain and the vertex at the center domain outlet to create an edge there. Next, let's join the newly created vertices to form edges. The Revolve tool in GridPro's CAD panel can be used to revolve the linear edges through 360 degrees. Also, let's close the domain at front by revolving the edge. Heal the geometry with default tolerance to merge small gaps and make it watertight. Surface labels and meshing. Surface labels can be assigned in the CAD panel. This makes it easier to load the surfaces as group after generating the surface mesh. Click on Add New Face Group button and label the domain surfaces. After this, let's generate a surface mesh to generate surfaces from the CAD model. Meshing parameters can be adjusted as needed to ensure that all nozzle features are captured accurately. Once the surface mesh is generated, load it group-wise. As you can see, the surfaces are loaded separately based on their assigned labels. Switch to the Topology tab to create a topology for this nozzle. Use feature-based splitting in the Surface tab to split remaining surfaces based on the feature angle, capturing geometry precisely while meshing. Approach for meshing. We'll use GridPro's Autoblock Nozzle feature to generate the nozzle topology, then extrude it into the domain to complete the full topology. Clicking on the Autoblock Nozzle opens up the dialog box. As shown, the topology can be either one-sided or two-sided. For simplicity, we'll create a one-sided nozzle topology in this video. A schematic is shown with all the nozzle inputs. This is helpful to input the right surfaces in the respective fields. Inputs can be either surface IDs or the surface groups. Let's input the appropriate surface IDs for the respective fields. The wrap option isn't enabled yet. It will be available in future versions of GridPro. You can specify the number of inserts using the number of inserts option. We'll keep it at the default value for now. Like in the whole topology, the nozzle also has topology type options. We recommend selecting four-sided plus bidirectional topology, which creates two additional inserts in the topology. For sharp features near the nozzle outlet, internal surfaces can be controlled using the support surface parameters. We'll keep these at their default settings for now. Next, let's add the peripheral corners to corner group C9. This helps in copying the outer corners to the domain walls later. Click Apply to create the nozzle topology. Cross-section of the topology can be taken to visualize the corner positioning. Better positioning of the corners gives rapid convergence in GridPro. Let's take the corners at the nozzle inlet and pre-position them using the work plane. Fit one option can be used to fit the work plane to the selected corner sheet, and it can be moved by clicking on the Move button to reposition the corners. Similarly, add one insert near the throat of the nozzle and group the corners using the Get Adjacent Sheet button. Move the corners inside using the work plane and Move option. Also, reposition the corners on the rocket body. Corners near the nozzle outlet can be moved such that it can be projected in the domain walls to get complete topology. Extending the topology to domain. Group the corners to be copied to the domain by clicking on the external unassigned corners button. We will retain the corners only at the nozzle outlet using the Retain Selected Corners button. Select Do Not Inherit, as we don't want to reassign the corner sheets to the surfaces on which it is being projected. Make the domain outlet surface as current and copy the grouped corners to the surface. Now, external corners can be selected again in another empty corner group using the External Unassigned Corners button. Select the reference group as Group for better visualization. Remove the additional corners sitting at the domain outlet center from the corner group. And copy the remaining corners to the cylindrical domain wall. This creates topology for the complete domain. Assignment. In GridPro, assignments define the relation between the wireframe and the surfaces. It tells the grid smoother where to project the corners while smoothing the grid. Generic button can be used to assign the corners to the respective surfaces. Face group lists all the external unassigned sheets of the topology. We can simply click on the unassigned sheets and assign it to the respective surface by making it current. One surface by surface wrap can be created for the corner sheet assigned to the rocket body and domain wall near it. This creates a H-grid at the intersection of two surfaces. The next part is to check validity. The validity check shows that the topology is valid, but having 6-point singularity. We can run a G-grid on this topology to check the resulting grid. set the densities using the length-based feature and check the modified densities using the preview button. Run GridPro's grid smoother the G grid to see the output grid. Go to the grid panel and load the grid once the status bar shows 0 folds. The quality devaluation shows the grid has average skewness of 0.09 and max skew of 0.8. 6A slice can be taken in the grid to check the cross-sectional grid. Improving the grid. As can be seen, the grid has high density regions at the undesired locations. Additionally, the density inside the nozzle can be increased. This can be improved by adjusting the densities further. Go back to Topology tab and make the necessary modifications in the density. The grid can be restarted from the existing grid to reduce the overall grid smoothing time. Update the grid to see the reflected changes. As can be seen, the grid is visually smooth and captures the nozzle features precisely. The max skew got reduced to 0.82. Running grid further helps in smoothing the regions of the sparseness. We hope this tutorial was helpful in understanding the usage of the Autoblock Nozzle feature in GridPro version 10. If you have questions, feel free to contact support@gridpro.com. Thanks for watching.